Okay, yesterday, what did we do?
What did we do?
We did the GCF
checkpoint. I didn't finish it.
With the GCF checkpoint you did. And then there was the factoring trinomials with a leading coefficient of 1. A bunch of people did finish, about it's like half and half. Half did, half didn't. That would be the first thing we won't done today. Well, I say that and I want to do notes first. So, have you done your checkpoint? Aubrey accidentally left his at home. If you're in the same boat as him, that's fine. Get it to me Monday. I won't tap in the zeros right now, if I remember not to. You know I'm the worst at that. Okay, we still need to do the second though, Aaron. Oh my gosh, Miss Kaufman.
I can do it.
What's the second? Please do. Please.
Well, there's not. I did it all on a calculator, but I know the answer.
Well, just circle the answer. Okay. Is she right?
Yeah.
Okay.
Two. Just keep dividing by 2. Yeah.
Okay.
Like, I just did it on a calculator.
Cool. I'm good with it. We did GCF, and you had that down. We're doing factoring and leading coefficient of 1, you had it down. We talked about how you could cut these out and color them. I am going to give you, once I get done rambling, I have a tiny worksheet for you. You could, theoretically, Albert could say, I'll do this weekend, and get his pennant done, because I only have one hung up, and you ought to go see Ms. Asbury's room. Her whole room is full.
Yeah, and hers is all festive
and beautiful. And I wish we could be festive and beautiful. So we're going to work on our festive and beautifulness after we are math productive. But first, to be math productive. Okay, we got to swap up the boat a bit today. Obviously, for real, we have to do leading coefficient, not a 1. So this can be anything except 1. That's why they put A not equal to 1. I'm going to write that note to myself as well. There's a reason there's all these ninjas on all our papers. It's not just because ninjas are cute. We're going to use the ninja star method in order to factor. There's a kid in 4th period who got help from someone other than me, which is fine. I mean, yes, other people can do math too. Talk that. But someone showed him a different way than what I've been doing. And so that leads me to this warning. You go home and Google how to factor. There are lots of different ways. There's a way called bust them up. There's a way called slide divide bottoms up. There's a lot of different ways to factor. I'm going to do the star method, and maybe when we come back from spring break, I'll show you bust them up. Miss Compton didn't learn any of these methods. All I learned was guess and check. You guessed an answer, that didn't work. Oh, okay, try a different one. So clearly that gets annoying. So I really like this one. But maybe you don't love it, and you'll find a different one you love, but this is for me. Okay, I like this one because there's a set pattern. Every single time, certain things are going to go in certain spots. So, for instance, A times C is always going to go there. It's always going to go in that specific slot inside our star.
Why?
I'm going to show you. Okay. A is always going to go on either side. B is going to go on the bottom. And we're going to figure out numbers to put here and here. Okay, so as always in life, we have some steps. My step 1 is literally going to be plug in values. Meaning, in my star, I'm going to plug in, I'm going to make my own star. I'm going to plug in A, C, A, and B. So let's make us a problem. Here, let me pick one you have to do. That's a good one. Okay. I'm going to do 3x squared minus 10x plus 3. So step 1 says plug in values. What is my value for A?
3.
So where the A slots are, I'm going to put 3s. Are there any questions about that? Okay, what am I going to put down here in the bottom? Negative 10, because that's the B. Are there any issues about that? And then what do I put at the top? What do I put right here? Which is, okay, so, and then I can write it over to the side. Gavin actually did 3 times 3. That's how he got the 9, if you need to explain it to yourself. Okay, so far so good. I know you can't see colors, but it's brown. So far so good. You're with me on everything except Miss Compton. Clearly there's more to it than this. What are you going to put in those holes? So we're going to get to that. Our step 1 was plug in the values. Our step 2 is really similar to what we were doing in our brains when the leading coefficient was 1. When the leading coefficient was 1, we would ask ourselves, let me cover that up. We would ask ourselves what multiplies to give me that last term, what adds to give me the middle. Those were our 2 factors. I'm going to do something very similar today. My step 2 is I'm going to think what multiplies to give me not the last, but the first times the last. And if you like letters, then really I'm asking what gives me A times C? What gives me, and for our problem, it would be 9. So I'm trying to think of what's going to give me that value. So what times what gives me 9? Because the first times the last would be 9.
3 times 3 was 9.
3 times 3 or 9 times 1. Those are my only options. She's right. Okay, and then I also ask myself, I'm still doing the same old with the middle. What plus what gives me the middle? So first times last is really AC, by the way, if you want to put letters. And middle is really just B. So I'm asking myself what adds to give me negative 10. So really I'm just using the top of the star and the bottom of the star. What multiplies to give me that top of the star? What adds to give me the bottom of the star? If you'd rather think of it like that. Okay, well, Ty was listing off some stuff for us. I'm going to write it in little margin. So 9, we can do 1 and 9, or 3 and 3. And then, since the middle is negative, it's still the same things as we wrote before. C was positive. I was looking for a positive 9. So, since the middle was negative, both my factors have to be negative. So negative 1, negative 9, negative 3, negative 3. Which one of those adds to give me a negative 10? Negative 1, negative 9. Are there anyone who doesn't understand what I'm picking?
This is kind of like what we've been doing.
It's exactly like what we've been doing, except
Just, we had that little square, the star.
yeah, we got the star, and then we're going to have to apply it. So our answer is going to look a little different than usual. Okay, so you said negative 1, negative 9, negative 1, negative 9. Perfect. Are you surprised? Those 2 holes on the ninja star, I'm going to fill in with negative 1 and negative 9. And you're like, but Miss Compton, how do I take this ninja star and turn it into an actual answer? Because I need an answer, Miss Compton. Okay, all we've been doing lately, let me write on my bell ringer sheet. Do not write this down. All we've been doing lately is like x plus 1, x minus 5. But with the first, that just gives us the 1x squared. Our answers aren't going to look like that today. We've got to do something like a 3x and an x. So when we do the first, we actually end up with 3x squared. So our answers have to look a little different than they did in the past. So the step 3 is the only actually funky step. And it's really not that funky thanks to this star. So the star helps us reduce. So we're actually going to reduce, if we were to cover up the top and the bottom of the star, we're going to reduce 3 divided by 9, negative 9. What is 3 divided by negative 9? What does that reduce to? Negative, what goes in the numerator? I'm going to be very specific, so I need negative 1 over 3. Does everyone understand how I got negative 1 over 3? So again, I'm using the 2 sides, the side of my star, the 3 and the negative 9. I'm seeing what they reduce to. 3 divided by negative 9 is negative 1/3.
Why are you just doing that? Those 2?
Oh, I'm going to do the other opposite too as well. I'm going to do 3 and negative 1. I can't get my hand right. I can't cover up the 9 and not cover up the 3. Okay, so I need to reduce 3 over negative 1, and I get, oh wait, that doesn't reduce.
No.
So I'm done. Okay, you're like, Ms. Compton, you're not done. That's not an answer. So ta-da is really we reduce the star, which we did. And you really just reduce the sides of the star, if you want to put that. Reduce sides of star. And then we somehow have to write our answers. So that reduction actually helps us write our answers. So our answers are, the numerator gives you the x, the bottom gives you the number all by itself. So our answer is actually 3x minus 1, because you told me 3 over negative 1. And my other factor, since it reduced, and it's just a 1 in the top, it's 1x, but you know I don't write that, x minus 3. Okay, so let me zoom out and say those words again. Reduce star and then right answer. So we reduced our star, and you understood how I reduced it. We take what we got when we reduced it, and that's actually our two factors. So the one binomial is 3x minus 1. The other binomial is x minus 3. Ma'am.
Wait, when you got the 3 over negative 1, why would you make that negative 3?
I do. I need to put, if I'm being really specific, I need to put that negative with the 3, don't I?
No, the other one.
The other one?
Was 3 over negative
You know how we don't like to have, would you really, when we full stuff out, do you like to see a negative at the very front? So if we're thinking through in life, you could either write this as 3x minus 1, or you could write negative 3x plus 1. Is that what you're asking me? Who does the negative go with? Okay, looking at this. Allison, looking at this. You're trying to ask me who does the negative go with, right?
No, I was saying, like, you said it didn't reduce, but it could be just negative 3 and then the numbers go away, right?
Oh, I understand what you're saying, but we take this fraction, the top thingy goes by an x, the bottom thingy is all by itself. That's what I did, 3x minus 1. This one reduced, so 1x minus 3. Again, numerator gets the x, bottom doesn't get any.
So we have to keep it a fraction to do the...
To write it like that, yes.
Oh, okay.
Yes, and I'm going to near at least 2 more of these on the back here.
Whenever you add it to negative 1 over 3, why wouldn't you count the x as negative?
We don't like to see the x term when we FOIL. If you pay attention to all our worksheets, the x term is never the negative. We always send it to the guy who doesn't have the x. I know that seems really silly, but anytime we're doing FOIL, or anytime we're talking about multiplying two binomials, the x's are positive values. Okay, and then Josh has an A for a reason, because Josh, what would you do from here? How do you know you're right?
Check it.
You could check it. So I didn't leave enough boxes, but Josh could actually FOIL this out. He's got 3x squared minus 9x minus 1x. That's minus 10x. And then he's got negative 1 times negative 3. Oh, that's positive 3. He ends up back at his original. So still, no matter what, everybody in the room can check it by FOILing.
I have a question.
I have an answer.
Is our test going to have, like, all of this stuff on it?
Yes.
Because I'm going to be so
Yes.
lost.
But don't you think we're going to spend a lot more time until we suddenly test? So our plan is to spend even time after spring break on this. Like, we need to get it down.
Okay.
But we're gonna do like a project or something next week. Me and my guys were planning, but we're not gonna like test on it. We're gonna have to come back to it after spring break, because this is like, if you don't get this in Algebra 1, then they're gonna think you had a bad Algebra 1 teacher. And YouTube does not need to think that. You're gonna ruin my YouTube reputation. Don't do that to me. Okay, flip to the back and let's do 2 more. I need to find problems. Okay, so not all problems work, as you've seen from that color by number thing the other day. Remember the one where you could just factor out the GCF and then you were stuck? So not all problems work. So Ms. Compton can't just do this game where she just makes up numbers off the top of her head. Life doesn't work well that way. Don't know why I just don't grab my handy dandy textbook. So I stole one from your worksheet. But what fun is that if I work through a whole worksheet?
That's fun for me.
I'm glad it is for you. It's not fun for me.
You know, life isn't about fun. So
Is
I'm
it?
not having fun.
Is it not?
It's not.
Okay, so I'm going to flip to the back and do 2. The first one I'm going to do is 3x squared. No, I got to think for 3s today. Plus 17x plus 10. Okay, so I make my little ninja star. I did not do that well. My ninja star is crooked. I need to make a different ninja star over here. Pretend that ugly one never happened. Ninja star. Okay, again, in the top goes A times C. So what should I put here?
A.
30.
30, because A times C is 3 times, how did I get the 30? I did 3 times 10.
10. Okay.
Okay, and then the A's go in these slots, so I'm going to put a 3 and a 3. The B goes in the bottom, so I've got 17. Okay, we really use each part of this ninja star. We start by using the top and the bottom to figure out two factors. Then we take those factors, plug them in, and use the stuff on the sides to reduce.
So the number in the front, so like the 3x squared, that's the A. The 3 is the A.
Yes, that's the A, that's the B, that's the C. Yes, ma'am. That is correct. Okay, so I've got to think through my factors this time. I need two things that multiply to give me the top of that star, so the 30, and what multiplies to give me, adds to give me, good grief, the bottom of that star, which is the 17. So stuff that multiplies to 30, that also adds to 17. If you still need to, of course, you can still write out a little factor chart. I don't think we need it that time. I think we have it, and we did. 2 times 15 is 30. 2 plus 15 is 17. So I take the 2 and the 15, and I plug them in my ninja star. My ninja. Okay, so I've got two fractions, and I need to see if they can reduce. It's okay if they can't. So I've got 3 over 2. Does that reduce?
So 1 over 5. Oh,
3 over 2. Does that reduce?
I should do the other one.
Okay, so, yes, you are.
Sorry.
Yeah, that's perfect. I'm good with it. Okay, so what do I write for my first factor then?
3x minus plus 2.
3x plus 2 is correct. Again, the numerator goes by the x, the bottom, he gets nothing. Poor bottom. And he always gets stuck with the negative 2. It's just a pain. Okay, and then 3 over 5 does reduce, and I already said it, it's 1 over 5.
So it's going to be 1x plus 5. It's just
Yes,
plus 5.
but I'm not going to write the 1, so just x plus 5.
And then you can FOIL to get your answer.
You could FOIL to make sure you got back to the original, so you know you're completely correct. I sometimes don't even write it, I just do it in my head. 3x squared, 15 plus 2, that's 17, plus 10, I know I'm right.
Yeah.
I know I'm right. Are there any questions about this?
Are we going to have a checkpoint on it?
I'm sure we are one day next week, that is, of course. Let's do one more on this. Let's do, one more. No, not that one. Oh, you'll love me for this. Again, Miss Compton with the 3s. 3x squared minus 11x minus 20. I make my star. I put my A's where they go.
So it's going to be 3 times 20.
Is it negative 20 though? So you get negative 60. So again, there's potential for issue because if you forget those negatives, you end up in trouble.
And then the bottom is negative 20.
The bottom is what?
No, negative 11.
Negative 11. Perfect. Okay, and then,
Remember.
oh yes, so many things. Then I ask myself what multiplies to give me negative 60 and adds to give me negative 11. So clearly somebody's got to be positive and somebody's got to be negative.
10 times negative 6.
10 and 6 give you
Wait.
60, but 10 minus 6 is just going to be 4.
Yeah, so you're going to have to do.
There's got to be something else that multiplies to 60. 5 times something. 5 minus 12 is 13. That's not going to work. So I guess I need to make my chart. 60 was 1 and 60. That's not a good one. 2 and 30. That's not a good one. 3 and 20. Still not a good one. 4 times what? 60. And I'm done. Why am I done? Because 15 minus 4 is 11. So it's going to be, which one's negative, the 15 or the 4?
15.
15.
Why the 15?
Because if it's like something's negative, then the biggest
Because
Yes, that is true. If the b is negative, then the big number has to be negative as well. Perfect. And then also, just because you're good at math, you realize plus negative 15 plus 4 is negative 11. Okay, and negative 15 times 4 is negative 60. We agree on that. So I put the negative 15 over here. I put the 4 over here. Does it really matter what spot I plug them into on the start, on the two sides? No, I could swap the 4 and the negative 15 if I want to. One side doesn't reduce. Which side doesn't reduce?
the right side.
The right side doesn't reduce. So I know that factor is just going to be what? 3x plus 4. The left side, oh by golly, it does reduce. What does it reduce to?
X minus 5.
I'm going to put 1 over negative 5. And then you're right, it is x minus 5. Okay, and then back to Allison's original question. Why does the poor denominator get stuck with the negatives? Every time we've FOILed, we've always had positive values in the front with the x's. So if you've got to decide who gets the negative side, it has to go in the denominator, so it goes in the back. Okay, and then Allison wants the easy A. Yeah, so easy. No work required at all, right? So she FOILs it back out. 3x squared plus 4x minus 15x. That's minus 11x. Negative 5 times 4 is negative 20. She knows she's perfect. Is everyone good with the Ninja Star?
Yeah.
We're going to Ninja Star it next week, too. I swear that's as hard as it gets. There are other methods, though, so I'm warning you.
I like this is the easier to me than the